Sure.
So, Snap4City is a platform for rapid implementation of sustainable smart solution and decision support system with almost no coding or low coding approach. So for us, a digital twin is a full stack from data collection to three-dimensional representation of the single building on which you can interact with all details that you may have, and also at the global level for the whole city. In addition, in this stack, we have a number of data analytics for making predictions, simulation, and what-if analysis, that is a full decision support system for the decision makers. I am going fast. So the stack,
okay.
The architecture is reported in these slides. So the platform is multi-domain, so we can cope with different kinds of area in so mobility and transport, energy, security, building, agriculture, parking, industry, and so on. All these kind of pillars that you may have, or the gateway that you collect for you or work with the data, can be connected to the platform to push the data or receive the data or provide the data, and this is a bidirectional channel. So the platform is capable to join a legacy solution that you have, or to implement specific solution in the platform directly. The platform collects all data, organize the data with an ontology, and the ontology is a support for making a spatial-temporal reasoning about all the entity that you may have in the city, in the infrastructure. And you can perform your data analytics. You can use our data analytics or our tools, and there are a number of tools for data representation, from just statistics data or time trends or maps or synoptics or three-dimensional representation. So the platform is fully open source, is powered by FIWARE platform, is an official platform from FIWARE. It passed the GDPR test, also penetration test, is an official library of Node-RED, and so has a number of plates, let's say. So there is also a living lab support in which you can work with the platform, and there is a well-defined and consolidated methodology for developing application on the basis of the platform. So the platform in Europe is quite diffuse. We have 11 installation of the platform in different countries, and several running projects. In the largest installation that is the one that we manage directly, we have 19 different organizations and tenants with more 88,000 users, with more than 1,600 dashboards and so on. So you see the map of data coverage that we have in Europe. We are also with the IDT in Australia, and we are in Brazil, Israel, Colombia, India, China, and so on. So the platform is interoperable, so there are a large number of formats and protocols in which we are interoperable and compatible. So I am going ahead. So the platform is capable to collect data, but also provide data with all kinds of sources that you may have based on brokers or geographic information system, SICAN network, satellite, or other kinds of API gateway or whatever you have. and all this the architecture is grounded on this approach here. So any kind of application that you develop creating some flow with Node-RED that I am going to show you later, which is a visual programming environment, or you can add some data analytics by using Python or RStudio for machine learning, AI, or explainable AI, even in parallel or massive computational architecture. And you can create your smart application exploiting the graphic representation that we have, like so three-dimensional digital twin, or dashboards, or synoptics, or other things. The platform can be federated with the other platform of the same kind with the Smart City APIs. And so you can add any kind of brokers. You can interoperate with any kind of solution, even for the single sign-on and for the authentication and authorization mechanism and so on. So the dashboard, the solution is based on an ontology. The ontology is called KM4City. KM4City means knowledge model for the city. It is the core for a sort of expert system for semantic queries. So you can really pose spatio-temporal and relationship query on all the infrastructure and the element and the entity that you may have in the city. The activity of data ingestion, data transformation, even management for many, creating new devices, new entity, or delegating access to the data, or governing machine learning, all the other things are controlled and may be controlled with a visual programming environment based on Node-RED. That are each process is automatically managed in cloud with container, and you can also install the same flows on edge. Even on TV cameras, there are some ARM 7 or 8 cameras that can host this kind of process, also with Raspberry, Linux, Windows, and so on. So you can really create your edge and cloud data transformation and data collection mechanism using our infrastructure and microservices. All these are microservices. So once you have collected the data can be used to create a dashboard with a tool that is called the Dashboard Wizard. Dashboard Wizard allow you with a few clicks to pass from the data to the visualization, to create animation or whatever you like with the complex data that you have. The platform manages a wide range of high-level types, for point of interest to routing or synoptics or dynamic icons, origin destination matrix, 3D model, trajectory, traffic flow, satellite data, workflow, or digital twins, beam, and so on. You see some of them here in the slides. I am going to show you more. These are some of the graphic representation that you may obtain. These are more, so you can change the skin. So you can select the style that you would like to apply to each of the dashboard. There are 7 different styles ready to use. If you would like to create your theme, or we can customize or create a theme for you, and it's very fast. There's a couple of files and you can pass from one theme to another with just one click. So this is a small example for smart building. I am going to show more later. We are strongly focused on SDG. You mentioned it before. This is just a list of some of our data analytics that we have focused on impacting on the SDG that are mentioned here. I think that we don't have time to go in no one of them for the lack of time, okay. Obviously. But we are ready to explain every of them, and I am going to give you some reference for this. So we have ready to use a number of data analytics for making prediction on traffic, on parking, on people flow, on maintenance, or lane slidings, or NO2, CO2, or many of them. Also flow for propagation of pollutant inside the city, taking into account the structure, the three-dimensional structure of the city, the direction of the wind, and so on. We do a lot of early warning. We do a lot of computation for city indexes like SUMI, PUMS, or 15 minutes city index of different kinds. And we do a lot of AI and XI with several different techniques. And also we do some simulation for traffic flow reconstruction, for routing, constrained routing, for matching demand and offer for mobility, for public transportation, and also what if analysis. What is going to happen if you change some part of your city, how the traffic will be rearranged, which would be the possible change in the pollutant propagation, and so on. So, if you would like to know more on this, there is a booklet, this booklet on data analytics and artificial intelligence, on which you can find detail regarding mobility and transport, user behavior analysis, or environmental and weather analysis, and also for management and strategy for early warning, resilience, and semantic reasoning. There is a course also here in the left bottom link that you see here in this slide. And so there is a full course that you can follow to understand how to use this kind of tools. We are in place since the 2017 with the control room of the smart city of Florence metro area. We are in several cities as mentioned before. This is one of the most complex and complete solution that we have in place for Florence, for the whole Tuscany. Tuscany is a region with 3.5 million and 500,000 of inhabitants, and with more than 40 million of tourists per year. This is an example of simulation and prediction for NO2 on the basis of traffic in Florence. The prediction is 24 hours, 48 hours in advance, hour by hour. I am going next. This is another people tracking by using thermal cameras in the front of Florence municipality. Now we are using this technology in Genova, Cuneo, Sweden, in several places with the same. So the system is capable to count and also track and understand the trajectories of the people. You see there an application in indoor. It works indoor, outdoor in the same manner. And also you allow the system with the other data that we collect from the app. We can create origin destination matrices in the city, also heatmaps or analysis of the user behavior in general. For the digital twin, so we collect all kind of data such as the traffic, in this case shown in the dashboard. We collect also pollutant, weather, all the data that you may have in the city, so for smart light or for smart bench or for water or for other things. So you see the possibilities of selecting the building in the in the global digital twin. They are colored in a different manner according to their meaning. This is just one kind of representation. This is a more realistic representation of the global digital twin. Again, you can select the single building, and it's also possible to see the traffic, to see the not only the traffic but also the pollutant. And the traffic is so you can see the traffic with the animated flows in the city that is going to appear shortly. You see the pin that you can click on the pin, so you can select with the selector on the left side which kind of pins or which kind of data you would like to have represented there. Let me see what is going now. Okay, now is going to appear the traffic. Traffic is it can be represented with this kind of crest, with the animated crests that are faster if you have a smaller density for traffic, and red if you have a higher density of traffic. You can go full screen. You can play with all these kind of things. We are working in this period also to move what you have seen before in the Oculus for virtual reality to have an immersive solution. You see now in navigation. This is one of the we are not in production with this, but for the rest, obviously, we are in production since several years. But for this, we are working on going in production probably with for September. This is we have so far a small part of the city at this resolution. For the BIM specifically, the BIM server and client are integrated in the system, so you can actually work with the BIMs. You can import in the system any kind of BIM design that you have produced with your professional tools. Presently, we are using this BIM server and client for web-based interaction, as you see here. You can attach to the BIM. You can manipulate, obviously, the BIM to see the observation, and you can also attach the pin regarding the time trends or time series, and so the actual real-time data that you can have attached to that specific sensor or to the specific element on which you have a real-time data, for instance, for an air conditioner or from some heating system or whatever. So the same things can be integrated in dashboard, and in dashboard you can have the same experience, and you can also have attached to the same pin other kind of representations, like the spider net, or the not only the time series but also the spider net or the bar series or other things. I think is going to be shown in a short time. So you can have maps, you can have a 3D global or local, you can have a time series. So all is you can pass from one to another in the different visualization that you may have. You can search them, you can connect them as you like. You can see or remove connection. You can. This is another example for an airport, for instance, in which you can have a floor, and you can connect the elements with some buttons in the graphic representation of the layout with the heat map of the people flows, and you can see the density. In this case, for the parking in that area. I think that there is more later. Okay, so in some cases we have connected the local digital twin with the details regarding the pipes or other element in the industry plant with the solution for making predictive maintenance. So to making prediction and connecting the prediction with the element in the three-dimensional representation of the digital plant. If you like to have more info and documentation, you can go in this booklet. You can download this booklet. I think Nicola is going to provide you the PDF for this.
Thank you. I was going to ask that.
Of these slides, and also we are going to provide you, I think, the video of this, the recording of this presentation. So we have this booklet that are quite nice to be browsed with a lot of pictures. They are going to be updated in September probably. There is also a technical overview, which is a bigger document, and there is also a programming tools, so a programming development life cycle document to understand how to develop, how to contribute to create your solution if you would like to do it personally, something like that. So there is some stories with the FIWARE. FIWARE is an international organization, probably you know, and this is the full course. So we have, I think in June and July, we have one meeting for this kind of course, 3 hours, 4 hours per week from 8 sections for the full course.
Okay.
It is planned. So